On the 30th November 2022, ChatGPT was officially released. 2 months later, it had crossed the 100 million user bar, making it one of the fastest adopted technology ever. Today, OpenAI's chatbot has over 200 million active users. Meanwhile, the largest water company in the world, Veolia, only serves 113 million people with that not-so-important service, I guess. How is it called already? Oh, yes, I recall, drinking water.
That was funny. That was funny.
Now I hear you. Comparing Veolia to ChatGPT is as relevant as asking who owns the largest yacht. Veolia's shareholders are super happy with the company's results, and 170 years in, it's safe to assume that all the founders are long dead.
That's sad. That's sad.
Yet, while Veolia is a largely undisputed leader on top of the water pyramid, there are about 1,500 startups at the other end of that same pyramid, for whom the question of the adoption of their technology takes a fully different meaning. For these brilliant founders and their team, it's a matter of life and death for their companies and of financial struggles or relative wealth for themselves.
Oh, I like money.
Try to put yourself in their shoes for a second. If you were to quit your job or refuse to take one when you graduated to go pursue your mission and grow a technology that can make the water quality better, treat wastewater more efficiently, protect cities and communities from water scarcity, or better anticipate and manage stormwater, just to name a few of the possible lanes those trailblazers are opening. How long would you endure the pressure of seeing your cash running short in waiting for that inflection point in the S-curve where your tech starts flying off the shelves? 2 months, like ChatGPT? 4 years, like YouTube? 7 years, like internet? More? Look, I'm 4.5 years into this water content journey. I have interviewed about 250 of these entrepreneurs, and even if I have a fraction of the skin they have in that game, I often feel that frustration when I watch the news or the latest political speech. I feel this desire to scream and break my TV and tell everyone, these guys, they have the solution. For God's sake, just use it. Yet the truth is, it takes longer, even if you have a winner technology. For their book, The Dynamics of Water Innovation, Paul O'Callaghan and his team reviewed 488 water technologies. Among those, they identified some of these winners that were right at the right time, the right place, and with the right teams, like the membrane bioreactor. Applied research for the technology started in the late 70s, leading to the first full-scale plant in 1990. It then took 6 years to reach the 100 references mark, then another 5 years to cross the 1,000 installations, and yet another 5 years to see MBRs spread in over 25 countries. And it's again 2 years later, in 2008, that the membrane bioreactor market size crossed the $500 million mark. So it took more or less 30 years for a winner to be in the middle of the market.
That's a long time.
And even that is actually a romanticized picture of the truth, because if applied research for the technology indeed started in the late 70s, the first patents were filed by Doe Oliver over 10 years before that, adding a layer of fundamental research to that timeline. Sorry to insist, but for the sake of clarity, I really want to emphasize this. If you were a PhD student in a university today, developing a potential winner technology, assuming you're right, you take all the right turns, build the right teams, and get the right win in your sales on the regulatory or macro end, you might see your tech become a banger approximately by the time when you'll retire. Now, I'm not saying this for the sake of painting everything black. Entrepreneurs rarely build a company from 0 to 1,000 all by themselves, and you can get a rewarding exit long before your tech makes it to the mass market, but those timelines are the grind you're embarking on. If you want a direct testimonial of that, I was blessed to interview one of the fathers of the MBR technology, Andrew Benedek, the founder of Xenon 2 years ago. The link is in the description. Yes, he sold his company to GE in 2006 for a sizable $656 million US, of which my personal estimate would be that his shares were about 120 million. But still, that was after 26 years, of which 20 were more or less about preaching in the desert. Just to prove that MBRs are not an outlier, here are more examples of winning technologies. Ultrafiltration membranes were piloted in the 60s and technically market ready by the mid-70s. Yet they had to wait until 1985 to get their first full-scale deployment in a drinking water plant. It then took 12 years to reach 100 deployment and then 9 more years to get to 1,000. So forgetting the R&D and estimated pilot times, from the first commercial reference to being in the middle of the market, it took 22 years. UV disinfection was slightly faster and also the fastest among all winner technologies studied by Paul and his team, with 20 years. Meanwhile, dissolved air flotation, which is a staple today in mining, oil and gas, and wastewater treatment, was first the slowest of the winners, with 36 years in the making. If we zoom out and leveraging the 488 techs they studied, the Blue Tech research team built what they call the Water Technology Adoption Model. It goes like this. Prior to properly entering the WaTA model, a water tech will spend 7 to 10 years in applied research. That time is spent in the lab and in tests that will go up to the bench scale. When the tech is ready to go out in the field, it enters the WaTA model with a pilot stage that will last for as long as it takes to reach a first full-scale installation. That typically takes 2 to 3 years. If I look back at some recent guests on my podcast, companies like Sudoc, Salinity Solutions, or Mangrove Lithium would be at that stage. Then the pilot will eventually turn into a demonstration plant where the tech is deployed at full scale in a commercial setup. The technology will stay in that bracket for as long as it doesn't have 3 units operating at similar scales in similar applications, which will take, on average, 3 to 5 years. Among my recent alumni, that's where you'll find companies like Membrion, Ionic Solutions, Swirltex, or Aclarity. Actually, my latest guest by the time I'm recording this, Martin Gross, the CEO and founder of Groschwen Technologies, would be a perfect example, even though the company has 3 commercial references, those being in 3 different fields. Their revolving algal biofilm would still be in the demonstration bracket. But back to the WaTA model, the next step is the early adopter stage, which starts, as explained, from 3 units at a similar scale and in a similar application, and would last until you reach 25 references, which will typically take 6 to 8 years. This is where you'll find, still in my podcast roster, companies like Zwitterco, Vapor, Hydraloop, or Epic Cleantech. Break the 25 references bar and you'll enter the majority segment where you'll be for 12 to 16 years still on average. Beyond the number of deployments, what changes at that stage is that your technology now gets specified by consulting engineering companies. It appears in tenders, and for sure, you also have competition. We'll see later that you wish you already had competitors before that. And that is not fully the end of the road, as so far your technology is not showcased in engineering manuals or taught in universities. When that finally becomes true, then your technology is mature. And hey, honestly, if you've been on that entire ride, you're probably mature too, right?
This is scary.
Indeed, let's recap. I'm still assuming for your mental health that you're not the person who started the fundamental research, as even if you were really starting in a university lab, professors and other researchers probably didn't let you start alone and fully from scratch. So let's assume your journey starts with applied research. You'll spend 7 to 10 years there, let's say 8. Then pilot for 2 to 3 years, let's say 2. Then demo for 3 to 5 years, let's say 4. Then chase early adopters for 6 to 8 years, let's say 7. Then strive in the majority tier for 12 to 16 years, let's say 14. And 8 plus 2 plus 4 plus 7 plus 14, that's 35 years. If you want to go show the engineering book that states your name at a family gathering, there are higher chances you show it to your grandkids than to your parents.
Oh, I don't know why I didn't think of that.
That's a dark thought. Sorry, let's erase that. Instead, let's ask this question. Do you need to accept your fate and prepare yourself for a 35-year marathon, or are there ways for you to accelerate your path? As much as there is no magical pill, the Dynamics of Water Innovation body of research identifies 3 levers that can still get you to market faster. Let's start with the one you can influence the least, the external factor. Paul calls it a crisis-driven type of technology, typically a water tech that does stuff better than the existing standard, which often comes at an increased cost. Historically, that's membrane bioreactors compared to aerated sludge processes, or that's ultrafiltration membranes compared to sand filters, or UV disinfection compared to chlorine dosing. In more recent examples, it's ion exchange to remove PFAS compared to, well, nothing, because you don't remove PFAS yet. Or it's ozone as a quaternary wastewater treatment to remove endocrine disruptors compared to, again, nothing. Or it's a thermal hydrolysis process on your sludge line compared with a simple stupid heater. It's not to say that those technologies don't provide additional value, but given that in water endeavors there is no premium for washing whiter than white, as an operator you may not be interested in that value in the first place, unless a major crisis happens like the cryptosporidium outbreak in Milwaukee.
need to go to the toilet.
I've already covered it twice on that channel, so I won't repeat myself here, but that makes ultrafiltration membranes suddenly much more appealing. It could also be a longer-term crisis, like the recurring water scarcity in California that nudges for water reuse, or an increased sensitivity of the population to a certain topic, like PFAS or pharmaceutical residues, that in turn gives a reinforced social license to the water systems that address it. But if we're realistic, the crisis alone, most of the time, doesn't get you past the early adopter group of end users. No, the real game changer is when governments react to that crisis and turn it into a regulation. As soon as there's a maximum bar for cryptosporidium or E. coli in water, there's a clear need to implement ultrafiltration or UV disinfection. Interestingly enough, and as I covered a while ago with Graham Pierce, link in the description, you know the drill, that crisis-driven nudge can result in a drop in price for the technology as it scales. And as a result, it can also become one-to-one competitive with the incumbent technology, even in fields where the regulation doesn't apply. Nowadays, ultrafiltration and sand filters are pretty close one to another from a price point of view, even if you leave the additional membrane benefits aside. For UV versus chlorine, not only is it becoming cheaper, but also a blessing as we better grasp the carcinogenic risks of chlorine byproduct. Sometimes that crisis-driven approach simply creates a market, like when the US EPA introduces a 4 parts per trillion limit on PFOA and PFOS, that could trigger a $31 to $48 billion market. If we zoom out, the technologies that tick this crisis-driven box go through the entire WaTA model about twice faster than their value-driven counterparts. So it's for sure an interesting category to be in. Large markets that open with regulation and faster adoption, what's not to love?
Nothing. It's perfect.
Well, just to nuance that a bit, it can also prove to be a double-edged sword, as Paul recalls in the book, with the example of ballast water treatment companies that developed processes in waiting for the double-digit billion-dollar yearly market about to open with the International Marine Organization taking new regulations that they ended up postponing forever.
One eternity later.
Companies simply died waiting. The second lever that can get you faster through the maze of water adoption is one you can influence, but not fully. In short, the idea is that you'll get traction faster if you have competition, somewhat aside from the consensus around blue oceans. In the book, Paul and his team cite here the example of MABRs with Oxymem and Xenon, well, DuPont and Veolia, to name the acquirers, leveraging their coexistence to enable purchasing departments and consultants to get more than one offer, or to write specifications that more than one company will be able to fulfill. And if you don't know what an MABR is, there is a third company that markets them, Fluence, and my interview with them is, of course, in the description. I hear you can't directly nudge competition, and it can somewhat be outside of your control to not walk alone. But by building in public, participating in open innovation approaches, and cultivating that openness, you probably benefit not only the greater good, but also yourself. It is honestly not really a coincidence to see that technologies tend to develop in clusters with, for instance, the Danish ceramic membrane players that somewhat all grew from the same tree, or the Swiss-Austrian rapid microbiology players that put some research efforts in common. Not to name Suez and Veolia that were growing in a symbiotic hat race out of the French city of Lyon for 1.5 centuries before ending that story in the Highlander fashion we saw 3 years ago.
In the end, there can be only one.
Finally, the third lever you can play on, that's also the one that's the most in your hands as a water entrepreneur, is self-awareness. If you're developing a value-driven technology that is, by definition, of a better price-benefit ratio than the incumbent, how much better is it? Well, Reinhard Hübner had set the bar on my microphone at 20% better. In the book, Paul O'Callaghan goes to 30% as the threshold you should have in mind. His advice is simple: if you're over 30% better, walk alone and push your relative advantage to undercut the incumbent, possibly by adapting your business model. Then, if you're better but by less than 30%, you'd rather think of licensing your technology to one of the established players. If you look broader on that one, it boils down to this: you won't market a radical functionality innovation like a discontinuous innovation or a sustaining innovation. The book goes in greater depth into that part, and while I've paid for the book and haven't received a cent from Blue Tech to tell you this, if you struggle to position yourself on that self-awareness map, their consultancy service is one phone call away. before I tell you what I think of the book, there's one more topic I'd like to swiftly address. It's the financing of this water technology ecosystem. At first, one may question why it matters to differentiate a technology at demo stage from one that's in the early adopters phase. After all, it's not like you graduate or win a prize. But timing actually matters, and even if averages are not meant to be an accurate description of the future, they still count, as different stages for a water tech company will attract different types of capital. The dedicated water VCs like Pure Terra Ventures, Burnt Island Ventures, or Eco River Capital will want to hop on an entrepreneur's first funding round. Yet their funds also have a typical 10-year deadline, which means that it's in everyone's interest that at least a partial exit is achievable within that time frame. In the same order of idea, players like Emerald, Science Water, XPV, or even Ski on Water, I might be dropping you more links in the description, maybe not. You won't know if you don't check. They will want to get involved in later stages, each of them having a specific window of opportunity that best suits the expectations of their LPs, so it's probably in everyone's interest to have a common understanding of the adoption field. To that extent, Paul's book proposes yet another additional classification of the technologies in 3 levels, with 3 criteria to mark that tech, namely number of reference plans, number of countries that adopted it, and annual market value. So if you're an analyst for an investment fund, you probably want to read chapter 6 with great attention and focus. My 2 cents. Which leads me to my personal feedback and feelings on the book. First, should you read it? Yes, absolutely. You actually have no excuses. It's short, synthetic, and straightforward. And if you don't want to spend any money, Paul O'Callaghan's PhD, which served as a basis for the book, is still available for free as a PDF online. And who knows, it's maybe even linked in the description. But should you read the actual book? Well, even if you have already read the PhD, there are new things in the book. More editorial comments, a bit more context, and an entire additional chapter, plus more illustrations and add-ons that previously were only available in Paul's keynotes at the Blue Tech Forum. Oh, and there's also this quote: "Please press the like button. That helps a lot with spreading the message, but you do you, no obligation, it would just be kind." Is it really in the book? Maybe? Now, the book isn't perfect either. You can feel where it is a new section and when it is a reprising of the PhD. Some anecdotal parts of some chapters will either repeat themselves just a tad too much, or with slight contradictions. For instance, a 25 years that becomes a 30 years. So by buying the book now, you're an early adopter. I'm pretty sure all of this will eventually be cleansed of the last 1% of the artifacts in a future re-edition. But hey, if that book is written for you, you're an early adopter by trade anyway, right? And it's really 1% I'm nitpicking on just to not appear too much of a fanboy.
Too late. Too late.
Now, if the 20 minutes or so we've already spent together are not enough for you to fully grasp the depth of the topic, I've also interviewed Paul to discuss the book at a time when the book was still under embargo, so at a time when I had only the PhD thesis to build on. It's nevertheless a long overdue update to my seminal interview with him 3 years ago. So if that's of interest, just click here, it's available on the podcast channel, and I'll see you next time.